Greetings math lovers and welcome to this next video of the series Math Olympiad Training Problems of 2025. The problem we have selected today is a number theory problem, and it states that prove that if the number 2 to the power 2 to the power n plus 1 is a prime number, then it cannot be expressed as a difference of 2/5 powers. So, as always, please pause the video, and if you have any solution to this problem, please write it down so we can compare our solutions at the end of this video. We have covered, as always, the solution to go through it step by step together. So, what we do is that we rewrite the request of the problem, and we have that we are asked to prove that when 2 to the power 2 to the power n plus 1 is a prime number, it cannot be expressed as a difference of 2/5 powers. As we often do in this channel, we will argue by contradiction. Let's suppose that indeed 2 to the power 2 to the power n plus 1 can be expressed as a difference of two prime numbers. We take m and k from the set of natural numbers, and we have that our expression is equal to m to the 5th power minus k to the 5th power. This will give that 2 to the power 2 to the power n plus 1 will be equal to m minus k times m to the 4th plus m to the 3rd k plus m squared k squared plus m k to the 3rd plus k to the 4th, where n, m, and k are part of the set of the natural numbers. So this is the expression number 1. Now in the equation number 1 over here, given that the left-hand side is a prime number, then the right-hand side will also be a prime number. But we see that the right-hand side is a product of two expressions. So in order for the right-hand side to also be a prime number, one of the two expressions should be equal to 1. And of course that this expression cannot be equal to 1 for any m and k from the set of natural numbers, so m minus k should be equal to 1 in order for our initial supposition to be correct. So we will have that m minus k is equal to 1, and from this we deduct that m is equal to k plus 1. Now, by substituting a equal to k plus 1, the equation 1 becomes 2 to the power 2 to the power n plus 1 is equal to m to the 5th minus k to the 5th, or is equal to k plus 1 to the 5th minus k to the 5th minus 1. We have, in this case, we have taken the plus 1 of the left-hand side and taken it to the right-hand side, and we have substituted m equal to k plus 1. Now, by doing the simple operations on the right-hand side, we get that 2 to the power 2 to the power n is equal to k to the 5th plus 5k to the 4th plus 10k to the 3rd plus 10k squared plus 5k plus 1 minus k to the 5th minus 1. Now we can simplify k to the 5th and 1 with minus k to the 5th and minus 1, and we will factorize 5 for the elements left on the right hand side, and we will get that 2 to the power 2 to the power n is equal to 5 times k to the 4th plus 2k cubed plus 2k squared plus k. We will call this the equation number 2. Now, in the equation number 2, we see that the left-hand side should be divisible by 5, because the right-hand side, it is divisible by 5. So, let's now prove that 2 to the power 2 to the power n can never be divisible by 5. For facility, let's substitute 2 to the power n is equal to p, and we will have that 2 to the power 2 to the power n is equal to 2 to the power p. Now, we know that the last digit of the number 2 to the power p is one of the numbers 2, 4, 6, or 8. But in order for a number to be divisible by 5, its last digit should be 0 or 5, which is always impossible for the number 2 to the power p. So this means that our initial supposition that 2 to the power 2 to the power n plus 1 can be expressed as a difference of 2/5 powers is false, which is what we originally wanted to prove. So when 2 to the power 2 to the power n plus 1 is a prime number, it cannot be expressed as a difference of 2/5 powers. Now, a little bit of let's say of exercise that can be left to the viewer is that you can convince yourself why 2 to the power p can never end with another number beside 2, 4, 6, or 8. So, thank you for taking time to have a look at this video, and thank you if you decide to like, comment, or subscribe to our channel. Your time is very much appreciated. So thank you once again and hope to see you on our next uploads. Up to then, goodbye.